Hi everyone, how are you all? I wish and hope you all are fine and doing good. And let's start our today's class of number system. Uh, so you all know what we mean by number system. Something which deals with numbers. Numbers means it could be anything. So including the operations. Numbers, including the operations, is called as number system. So now now look at this question. Of course, you all know like numbers means you have integers, you have whole numbers, you have natural numbers, rational numbers, irrational numbers, anything, but whatever it is, he'll mention. Those numbers operated with four operational signs is called as number system. So if you look at this question, when an integer n is divided by 2, integer n he says, but he did not tell whether it is positive or negative, nothing is stated. So we don't know what it is, therefore simply we know it is an integer. Is divided by 2, the quotient is u. The quotient is u and the remainder is 1. Okay, so that means n can be written as 2u plus 1. Okay, so that is the thing. When an integer n is divided by 5, so 5v, and the remainder is 3, so means plus 3. This is what we get. Which of the following must be true? So look at this. So this is n, this is also n. Both are n, so equate these two. So 2u plus 1 equal to 5v plus 3. So what is that suits you more here? So this is option B. 2u minus 5v equal to 3 minus 1 is 2. So option B satisfies. Please note it fast, quick. Yeah, let's go to the next question. I think you have completed this. So now look at this. Suppose P is even and Q is odd. Even means 2 times something we write. Odd means 2 times something plus 1 is odd. Right? This is the way we represent the numbers, odd and even. And this he says P and this he says Q. Okay. So now which of the following cannot be an integer, he says. So here P plus Q means even plus odd is odd. Odd by P means even. So odd by even can never be an integer, isn't it? Odd, P is even, plus Q is odd. So even plus odd is odd. Odd by even can never be an integer. So it's always a fraction. Like for example, 3 by 2, 1.5. 5 by 4, 1.25, like that. So everywhere it becomes decimal. This is not integer. So therefore option 1 is cannot be an integer. Let us look at 2. PQ by 3. So odd number, this can be 6, 3, 9 or anything. So therefore this can be an integer, if not for sure. Q by P square. See, Q is even. Even by odd square is odd only. Even by odd is again a decimal. So option 1 and 3. So you have D here. Okay. Please note it quick. Yeah, let us go to the next question. Yeah. So now look at this. A comma B and C are consecutive integers. Consecutive means what? I can say n. Now let us see which is bigger and which is smaller. C is largest of all. So consecutive means n plus 1, n plus 2, like this. So ABC are consecutive integers, he said, but he did not tell which is even, which is odd. Nothing is told. So n can be even or odd. If n is even, this is odd and this is even. If n is even, then this becomes odd and this becomes even, like that. Okay. So now, what is that question? He says, which of the following must be true? So this is A, this is B, and this is C. B minus C should be minus 1, not 1. So this is wrong. Option 1, I mean 1 is wrong. 2. ABC by 3 is an integer. C, for example, n is 2. So this becomes 3, this becomes 4. So ABC will be like this. So ABC is always divisible by 6. ABC is always divisible by 6. Therefore, he says by 3 is an integer. So when it is divisible by 6, automatically it should be divisible by 3 also. Therefore, this is an integer. Okay. A plus B plus C is even. So this you should think. Suppose A is odd or otherwise N is odd. Odd plus even plus odd is even. So this can be even. But if I say first is even, even plus odd plus even is odd. Therefore, this cannot be even all the time. Only if A is even, then sum of the three will be. I mean, if A is odd, then sum of the three numbers can be even. If A is even, then it is not even, it is odd. Therefore, only 2 satisfies. So B. So please note it fast, quick. Take screenshots so that we'll go to the next page. Right? So let's go to the next page. Note it quick. Yeah, screenshot. So it should have been done. Let us go to the next question. If both x and y are prime numbers, which of the following cannot be a difference of x and y? So both are prime numbers, he says. So we have only one even prime. 2 is even prime, right? Remaining all are odds only, except 2. Remaining all prime numbers are odd. So now look at this. So he says, which if both x and y are prime numbers, which of the following cannot be difference of x and y? So he did not state x is bigger or y is bigger, nothing. So let us write the prime numbers 2, 3, 5, 7, 11, 13, 17, 19, like this. Okay. These are the prime numbers, etc. So many. So he says, which of the following cannot be difference of x and y? He says, 1, yes, it can be. 3, just check if 3 can be difference or not. 9, it can be the difference. 23, so 3 you just check. 5 minus 2, you have 3 or not. So this can be, this can be. Then 9, 11 minus 2 is 9, 23. So the leftover option is only 23. It is possible. I mean, it is not possible because 19, then comes 23, Then comes, see, this is an odd number. How to identify? This is also important. All these are odd numbers, correct? All these are odd numbers. Now, if you have to get a difference of two numbers is odd, one number is odd and the other number is even. Then only you'll get odd minus even is odd. If both are odd, odd minus odd is what? Even. So therefore, we should always keep 2 in loop. Should always keep 2 in loop. So 3 minus 2 or 5 minus 2 or 7 minus 2 or 11 minus 2 or 13 minus 2 like that. Then only you'll get odd number here. So if you have to have 23, you should have prime number as 25. Is it possible to have prime number as 25? No. Therefore, answer is only D. So by looking and observing itself, you can state uh, the answer. You don't need to try fully and then do it. Okay? Please note it fast, quick. So students, here we don't need to check. The only logic you should observe is if all options are odd, then the difference means if you take x minus y, this y should always be 2. Then only odd minus 2 is odd. If you can identify this logic, finish. There is nothing else to do. So with this, if you'll understand, if answer should be 23, 23 plus 2 should be an odd number, I mean a prime number. Finish. So you need not check options, nothing. Simply directly you'll go to the answer. Okay. Logics. We call it as logics. Next question. If the remainder is 1 when n is divided by 2 and the remainder is 3 when n is divided by 4, which of the following must be true? So let us write the equations. M is what? Remainder is 1 when it is divided by 2. So 2 times Q1 quotient is Q1 and plus remainder. Remainder is 1. N is what? Divided by 3. 3 times quotient is 2. That's Q2 we call, just for differentiation. Plus 4. So why should plus 3, sorry, divided by 4 he says. So this is 4 and this is 3. Or we rewrite this. N equal to 4Q2 plus 3. Okay. So now let us see which of the following must be true, he says. M is even. No. When we add 1, so that means it cannot be, this may be, if 2Q1, this is always even. 2Q1 is always even. Even plus 1 is always odd. So this is also even plus 3 is odd. So now, so that means M is even, he says. That is wrong. N is even. No, we just see it is odd. M plus N is even. Yes. Odd plus odd is even. So this is 100% true. Mn is even. No. Odd into odd is odd. So therefore, the answer is C. Answer is C. Please note it quick. Okay. Yeah. So let us move to the next question. So look at this. This is all same explanation what we did. Yeah. Now look at this. If x and y are both prime, if x and y are both prime and greater than 2, both prime greater than 2 means x is odd and y is also odd, because greater than 2 all are odd only. Okay. Then which of the following cannot be a divisor of xy? Xy is odd into odd. Okay. Which of the following cannot be a divisor of xy? So let us check at that. See, xy is odd. Odd cannot be divided by 2. So it can be divided by 3 because 3 is one of the prime numbers. C, 11, it is one of the prime numbers. 15, if x is 3, y is 5, something like that, then D is also possible. The only option which cannot be a divisor of xy is 2. So it should be option A, right? Please note it quick. Right? Have you completed, children? So let's go to the next question. Yeah, look at this. If 2 is the greatest number, if 2 is the greatest number that will divide evenly both x and y, what is the greatest number that will divide evenly both 5x and 5y? So 2 is the greatest number that will divide evenly both x and y. So 5x and 5y, he says. Now, uh, look at these answers: 2, 4, 8, 10. So now look. See, since 2 divides evenly into x, so we get x as 2 times something. So let us call it as 2z, right? X is something like 2z. Okay. So now next 5x, he said. 5x is 10z or not? 10z or not? Now, similarly, 5y will also be multiple of 10 into something. Z1 we call. Okay. So now this is divisible by 10 and this is divisible by 10. So what is the greatest number that will divide evenly both 5x and 5y? Means that is option 4D, that is 10. So final answer is 10. Please note it fast, quick. Okay, let us proceed to the next question. If the average of the consecutive even integers a, b, and c less than a by 3 says, if the average of consecutive even integers a, b, and c is less than a by 3, which of the following best describes the value of a? So look at this. So that means here uh, average of ABC means what? A plus B plus C by 3. This is the average. So this is lesser than A by 3, he says. Okay, that is lesser than uh, if average of consecutive even numbers A, B, and C. Okay, so even integers means it can be 2n, 2n plus 1 plus 2, or 2n minus 2, 2n plus 4, or 2n minus 4. So this is how you get the things. Okay. So three consecutive even integers. So now, which of the following best describes the value of A? A is a prime, A is negative, A is 0, and A is positive. See, if you look at this, if I can say A is an even integer, the next consecutive integer is A plus 2 and that next is A plus 4. Okay. Now, if you take average of all the three, you'll get A plus B plus C by 3. So as we have written here, so A plus 2 plus A plus 4 by 3. So this you'll get it as A plus 2. That will get it as A plus 2. Okay. So now A plus 2 is less than A by 3. Okay. So now if you take this A by 3 to the left, you'll get it as 2A by 3 is less than minus 2. So A is negative. A is negative, right? So that means which option you see? A is negative, you are getting same. So that means final answer should be A is negative, right, children? So please note this quickly. Less than 2. A is minus 3, less than 0. So A is negative is option B. Please note it fast, quick. Right, children, let us go to the next question. Yeah. Now you see, if x plus 5 by y is a prime number, x plus 5 by y is a prime number, which of the following must be true? So x plus 5 by y, okay? So y equal to 5x, y equal to 5x. Next, y is a prime number, prime integer. X plus 5 by y is odd. So, uh, so now x plus 5 by y is a prime integer. Which of the following must be true? So, for example, let us take x is 1 and y is 3. X is 1 and y is 3. So, for the first, okay. So now 1 plus 5, 6 by 3 is 2, which is not equal to 5x, which is not equal to 5x. And now x plus 5 by y is 2. Okay, for this example of x is 1, y is 3, you'll be getting answer as 2, which is prime but not odd, which is prime but not odd. So now let us take some other number. X is 3, y is 4, because we are taking all divisibles only. So 5 plus 3 is 8 by 4 is 2. 8 by 4 is 2. So this is also a prime but not odd. So statement 2, what is statement 2? Statement 2 says y is a prime. So in this case, first case we have taken y, which is prime. Second case we have taken 4, which is not prime. So therefore, statement 2 is not necessarily to be true. So option is answer A. So please note this first page, then we'll go to the second page. Okay, let us go to second page so that you copy it. Please note the points. We'll go to the next question. Yeah. If x is both the cube and the square of an integer, and x is between 2 and 200, x is between 2 and 200, what is the value of x? So simple children, here between 2 and 200, you please note all the numbers which are squares, and you can pick which is the cube also of some number. So now what all are the squares? 4, 9, 25, 36, 49, 64, 81, 100, 121, 144, then 169, then 196, right? These are all the numbers which are squares. Now, in this, which is cube also, you pick 64. So 64 is 8 square or otherwise 4 cube. 8 square or 4 cube. So now, options you are given as 8. 8 is not square of any number. 16, it is not cube of any number. 64, we did it. 125 is cube but not a square. So therefore option is C. Okay. So now instead of doing this, using options, it becomes more simple in this case. So children, that's why you should understand whether you should use some logic. This is the logic. Or you should use options given, or you should use formula, or what. So therefore, different problems need different techniques. So based on that, you need to work on this problem could have been a better one using options. Okay. So let us look at the problem and then decide on which method to be used. I said there are 8 methods of solving objective questions. So therefore, one of those 8 techniques we'll be using. Okay. Children, you should observe when I use the sentence, I'm not saying problem. Very rarely I use the word problem because it slips out of the mouth. But I always say question. Means when you start looking at a question as a problem, it really becomes a problem. Therefore, don't look at the question uh, or talk about the question as a problem, or don't name it as a problem, call it as a question. This is very important. When it is a question, it becomes simple for you. So this is simple psychology I'm talking to you. But anyway, let's go to the next question. I think you have followed and you have noted this, right? So now, in the two-digit number x means if it is something like AB, let us say. So B is in units place, so B's value will be B into 1. A is in tens place, so A value will be A into 10, like that. This is very important, children. If some A, B, C like that, so hundreds place comes. So the place value of that first digit will be 100 into 100, like that. So based on the place value, we do that. In the two-digit number x, both the sum and difference of the digits is 4. Sum and difference of its digit is 4. What is the value of x? So, see children, this has 2. Let us call it as AB. X is called as AB. So now, sum and difference of these two is 4 means automatically the second term should be 0. Then only you will get 4 plus 0 is 4, 4 minus 0 is 4. So automatically the number is 40. It is very clear because 4 minus 0 is 4, 4 plus 0 is 4. Right, children? So therefore x is 40. Please note it fast, quick. Okay. Let us look at the next question. Now look at this. If p divided by 9 leaves a remainder 1, p divided by 9 means p equal to 9 times some quotient q, leaves a remainder how much? 1. Okay. So now, which one of the following must be true? See, plus 1 when it comes, this may be odd. If it is odd, odd plus 1 is even. So if it is even, 9q, if it is even plus 1 is odd. So now, as soon as I state this, people will look at 9 is odd, therefore this should compulsorily be odd. Why should that compulsorily be odd? Suppose let's say q is 2, suppose. So 18 plus 1, so odd, isn't it? This is not odd if it is q is 2. If q is 3, this is odd. Odd plus odd is even, like that. So p need not be even all the time. It can be even or it can be odd depending on the value of q. Depending on the value of q. If q is 2 implies p is what? 18 plus 1, 19. This is odd. If q is 3, p is 27 plus 1, 28. Even, right? So p can be even and p can be odd. Therefore, this is wrong. This is also wrong. So p is 3z plus 1 for some, yes, it is possible. See, p is 9q plus 1. This is 3 into 3q plus 1. This is 3z. Z is nothing but 3q. Okay. So you are getting this. So option 3 is right. So 3 only. Please note it fast, quick. Quick. Okay, let us go to next question. See, we are using just logic, children. We are not trying to use some solution or some process, nothing. Just logically, we are doing everything, just observing everything. So P and Q are integers. If P is divided by 2, the remainder is 1. So P is 2 times something, quotient 1. So remainder is 1. So this is odd. Clearly, it is odd. Okay. And if Q is divided by 6, so Q is divided by 6 means quotient 2. The remainder is 1. So again, this is odd children because 6 is even. Even into any number is even plus 1 is odd. 2 is even, so 2 into any number is even plus 1 is odd. Finished. So we know clearly P is odd and Q is also odd. So this is what is identified. Now, what is the question? Let us see. Which of the following must be true? PQ plus 1. PQ means odd into odd. PQ plus 1. That is odd plus 1. That is even. Right? So you got first option. Even, this is right. Second option. PQ by 2 is an integer. Yes. PQ, no. PQ is odd. Odd by 2 is not integer. Is not integer. So this is wrong. PQ is multiple of 12. No, PQ is odd we are getting. So not multiple of 12. So he says is a multiple of 12. So only option 1 is right. So only one, option A. Please note it fast, quick. Okay. Okay, children, let us move to the next question. I think you are very clear with this. The smallest prime number greater than 53. So simply you write your prime numbers and then check. Greater than 53 is 54, not prime because divisible by 2, 55, not prime because divisible by 5 and 11, 57. Is this divisible by any number? Yes, see, 3 you take. 3 ones 3, 3 nines 27, like that. So the only prime that is left over is 59. So look at that, option B. Okay, please note it fast. This is very simple, children. If you can write prime numbers, that is finished. Please note it fast, quick. Okay, let us go to the next question. Which one of the following number is the greatest positive integer x such that 3 power x is a factor of 27 power 5? 3 power x is a factor of 27 power 5 means this 27 power 5 should be divisible by 3 power x, means 27 power 5 can be written as 3 to the power of 3 into 5, that is 3 to the power of 15. So that means x should be greater than 15 or equal to 15, then it will be divisible. Okay, so let us see what happens. 5. So now what is that integer x such that 3 power x? 3 power x means 5 lesser than 15, 8 lesser than 15, 10 lesser than 15, d equal to 15. So answer is D. I said x should be, means if it is 3 power x by 27 power 5, this is 3 power x by 3 power 15. So x should be greater than or equal to 15. Then only it will be divisible by 5. So you have equal to 15. So answer is 15. Okay. Please note it fast, quick. Let us go to the next question. If x comma y and z are consecutive integers, x comma y and z are consecutive integers in that order, which of the following must be true? See, consecutive integers means what? I can start with x as odd, so y becomes even and z becomes odd. Or x I can start with even, y becomes odd, and z becomes again even. Okay, so this is what you have. So now which of the following must be true, he says. Xy is even. See, whether you take this odd into even is even, or this even into odd is even. So whenever they are consecutive integers, xy is always even. Xy is always even. Now x minus z is even. So look at this. X minus y means odd minus even is odd. Even minus odd is also odd. Okay. So therefore, x minus z is even is wrong. X square is even. Now you see, if it is this, x square is even. But here, x square is odd. Therefore, third cannot be right. So 2 and 3 cannot be right. 1 only is right. Okay. Please note it fast, quick. Yeah. Let us go to the next question. look at this. If the sum of two prime numbers x and y is odd, see, if 2 is even prime, all others are odd, all other primes. So now if you have to remain, sum of x and y has to remain odd, compulsorily 2 should be used. Then only odd plus 2 is odd. Therefore, one of the prime is 2 compulsorily, either x or y, whatever it is 2. Then the product of x and y must be divisible by compulsorily 2, isn't it? Odd into 2 is even, so it is divisible by 2. So option is A. So it cannot be divisible by 4 because 3, of course. If other odd number is 3, then it is divisible by 3. Otherwise, it need not be. Therefore, it is not compulsory. 4, no, not possible at all. 5, that is possible only if the y, if I say x is 2, if y is 5, d is possible. If y is 3, b is possible. But this is unconditionally true. Therefore, option is A. Please note it fast, quick. Completed. Let us go to next question. So look at this. If x plus y by x minus y equal to 3 and x and y are integers, then which one of the following must be true? X is divisible by 4, he says. Y is an odd number. Y is an odd number. Y is an even integer. So x is an even number. So let us try by taking final shape of this curve, 3x minus 3y, cross multiplied, and I got this. So 3y, bring it to the left, 4y equal to 2x, right? So x equal to 2y. X equal to 2y means x is always even. Okay, x is always even. X is divisible by 4, he says. So unless y is an even number, this is not true. So which of them must be true, he says, means this is not compulsory. Y, if it is odd, then it is not divisible by 4. Therefore, this need not be true. Y is an odd number. How can I say y is an odd number? Y can be even also. So this is also not true. Y is an even integer. So can't say. So not necessary. So x is an even number, 100% true. So option is D. So please note it fast, quick. I think this, instead of going to next page, I've written here. Please check it quickly. Right? Have you completed? So let us go to the next question. See, children, simple questions become very simple if you start using logics, if you start using analysis. Therefore, to have logical reasoning and analytical skills are very much important, along with having the knowledge of the subject you are doing. Okay? So we don't try to use any of the problems or formulae or definitions or concepts sometimes. Just use common sense and do it. Okay? Look at this question. Yeah. A two-digit even number, is such that reversing its digits. See, if I say x is two-digit number. So what is that? He says two-digit even number means b is even. It is clear. Okay, means it could be 2, 4, 6, 8, anything. By reversing its digit means ba. You have reversed the digit, so it becomes ba. Creates an odd number. This is odd. Means a is odd clearly. A is odd clearly. Okay. greater than the original number, means BA is greater than AB. BA is greater than AB. Then which one of the following cannot be the first digit of the original number? So let us see. We have analyzed and we have written certain things. So A is odd. So all four can be answers. Which of the following cannot be the first digit? See, based on this point, I can say all four are possible answers. Okay. But next, what is that he said? BA is greater than AB. BA is greater than AB. So BA means B into 10. So 10B plus 1 into A is 1A is greater than AB, 10A plus B. So now if you simplify, 9B is greater than 9A. So B is greater than A, correct or not? So uh, if you take 1, if you take 1 as what is that he said, which one of the following cannot be the first digit? Means if you take 1 as A, you have so many values for B, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, this can be answered. If you take A as 3, you have for B 4, 5, 6, 7, 8, 9. So that also can be answered. You take 5, you have 6, 7, 8, 9. So if you take 9 as A, you don't have any digit for B. So after 9, you have only 0. So 0 cannot be B. Therefore, answer is D. Right, children? So please look at this. See, if you don't take this, then you cannot get this answer. Therefore, this point has been of importance. Okay. So this I'm taking place values. A's place value is A into 1, B's place value is 10 into B. So total number is this. Okay. Please note it quick. Okay, I think you have taken screenshot. Let us go to next question. Yeah, now look at this. Let A, B and C be three integers, and let A be a perfect square. A be a perfect square if A by B equal to B by C. So A by B equal to B by C means B square equal to AC. Correct or not? So now, then which one of the following statements must be true? So now look at this. C must be even number. C must be even number. Why C should be an even number? Is it compulsory? Suppose you take 16. 16 is 4 square or not, so B is even. So if this is the case, it can be written as 2 into 8. Okay. Or if this is the case, you are getting C as even only. Let us take some other example. Uh, so let us take B square as odd number. So odd number square is always odd, so therefore C must be even uh, is wrong. What is it? This is one of statement must be true. So C must be even, he says. So it need not be even, isn't it? For example, you take 25, that is 5 into 5, or 25 into 1, or 1 into 25, or 20, that's all. Okay, these are the three possibilities. So C must be even, he said. So C need not be even, right? So next option B. C must be odd number. So not necessarily to be odd, you see. Here we got even, that is wrong. C must be a perfect square, not compulsory. You see, this is not a perfect square. This example you take, it is not a perfect square. C must not be a perfect square, he says. So that is also not true because you take here, this is a perfect square. So A, B, C be three integers and let A be a perfect. Oh, sorry, this we are taking B as a perfect square, not A as a perfect square. So then let us restructure it, children. So we have not noticed that all. So now A must be a perfect square, he says. This point I was not reading. A must be a perfect square. So A by B equal to B by C he gave. So AC equal to B square. AC equal to B square. So compulsorily B should be a perfect square. I mean B square should be a perfect square. But we should ensure that A is a perfect square. So like let us say 25 into 1 is 25. Okay. Now 16 is 4 into 4. Right? So in this case, B will be 5. In this case, B will be 4. So now let us reread all the options given. C must be even number. C, not compulsory to be even. So next, C must be an odd number, not necessarily to be odd. C must be a perfect square. Yes. You see, this is a perfect square. This is a perfect square. Anywhere you take when this has to be a perfect square, uh, compulsorily we should get a perfect square. C should be a perfect square. So option C satisfies, right, children? Option C satisfies. Please note it fast. Okay. From here you copy. Please copy it fast, quick. Let us go to next page. See, mathematically, if you come, you have B square equal to AC. Everywhere he moved around, C only. So is B square by A. Okay. He said A is a perfect square, so A is equal to given A equal to some kx whole square. Okay, or k square, yx again. So k square. So that means C equal to B square by k square. So that is B by k whole square. Of course, B is divisible by k, that is a separate thing. So C is a perfect square or not, so that way also you can tell. Okay, either that or this. There we have taken numerical examples. This we are using mathematical logic. Okay, children. So this is more appropriate than that method. But anyway, it doesn't matter. Please note it fast, quick. Let's go to the next question. Yeah, now look at this. If n is greater than 2, then the sum, S is sum, of the integers from 1 through n can be calculated by following formula. S equal to this, n into n plus 1 by 2. N into n plus 1 by 2. Sum is n into n plus 1 by 2. So this is nothing but 1 plus 2 plus 3 so on up to n. So this is what he says. Okay. Which one of the following statements about S must be true? S is always odd. S is always odd. So look at this. If n is even, n plus 1 is odd. Okay. So now, for example, let us take n is 4 and n plus 1 is 5. So 4 into 5 by 2. This is 10. Now, if I say 2 and 3, then 2 into 3. So n is 2, n plus 1 is 3. So by 2 is 3. So now S, this is S, isn't it? We are using the formula S. So S has become even, S has become odd. S is always odd, he says, not right. S is always even, he says, not right. S must be a prime number. Is 10 a prime number? No. So S must not be a prime number. No. This is also not true. S is always odd. S is always even. Uh, so none of the four options. So if you take S must not be a prime number. Yeah, S must not be a prime number means here you are getting not a prime. Here you are getting a prime. Also, sorry, children, here we are not noticing this. N is greater than 2. So therefore, n is greater than 2, this cannot be taken. So if you take greater than 2, then definitely S must not be a prime number. So therefore, option D satisfies. This point we did not notice, you see. So in mathematics, any statement given should be considered and we should proceed accordingly. Therefore, this point we were not observing and we have taken examples as 2 and 3. So therefore, this point should be considered. We neglected one of the statement or rule that he has given. Therefore, we missed this option. If we consider that, then there'll be no point where we'll miss it. So please note it fast, quick. Okay, children, let us go to the next question. Yeah. If n is an odd number greater than 5, n is odd greater than 5. So n can be 7, 9, 11, and so on. And a is multiple of 5. And a multiple of 5. A is 5 times something. Then what is the remainder when n is divided by 10? Okay, sorry. And a multiple. Greater than 5 and a multiple. So this should be removed. So this will remove. So now n is odd number greater than 5 and is multiple of 5, he says, means 15, 25, 35, and so on. Okay. Then what is the remainder when n is divided by 10? So whether you divide this by 10 or this by 10 or this by 10, any number, remainder is 5, right, children? So let us look at the options. So option C, please note it fast, quick. Okay, let us go to next question. Which one of the following could be the difference between two numbers, both of which are divisible by 2, 3, and 4? Which of the following could be the difference between two numbers, both of which are divisible by 2, 3, and 4? So what is LCM of 2, 3, and 4? So 12, right, children? 12. So that number, both of those numbers are multiples of 12. So 12, 24, 36, and so on. So now he is asking you to find out the difference between the numbers. See, when you take difference, it should be divisible by 12. So which of the following could be the difference between two numbers? So difference of two even numbers is even. Right? So these numbers is even compulsory. So this is odd, ruled out, elimination of option method. This is odd, this is ruled out. And now let us see it is 72 or 74. Okay. So now we know the difference should also be a multiple of 12. So 74 is not a multiple of 12. So that is also ruled out. So option should be B, 72. Okay. Please note it fast. Quick. Look at this. We have given the same mathematically also. Okay. Right, children. Let us go to the next question. Yeah. A number, when divided by 12, gives a remainder 7. So let us call the number as A. Divided by 12 means 12 cube. Leaves a remainder 7. So that means this is odd. That number is odd. If the same number is divided by 6, then the remainder must be what? What? So now, this is anyway divisible by 6. 7 if you divide by 6, you'll get remainder 1. So answer is 1. Please note it fast. Quick. Yes. Now let us look at the next question. Yeah. Look at this. Let x be a two-digit number. So x is two-digit number, means let us call it as AB. So this will be equal to 10A plus B, like that. Place value. I'm talking about place value. Okay. Now what is that he says? If the sum of the digits of x is 9, A plus B equal to 9, he says. Then the sum of digits of the number x plus 10. Sum of the digits of number x plus 10. So now look at this. So now look at this. If you take the two numbers and if you add up, that means A plus B equal to 9. Okay. So it should be 9 means what? 72, or 7 plus 2 is 9. Like that. Okay. Or 63 or something like that. So you can take 63, 54, like that you can take anything. So now if you add to the 10, x to the 10. So if you add 10 to this, you'll get 82, for example. Okay, we are taking some example and discussing children. So if you add again 8 plus 2, that is 10. 8 plus 2, you are getting it as 10. So now let us take another number, let us say 90. So 9 plus 0 equal to 9. So now if you take this number, x plus 10, so 90 plus 10 is 100. The sum of digits is 1. Okay. So if you take this example, you are getting sum of digits as 1 or sum of digits as 10. You see here 10. So it should be either 1 or 10. Okay, please note it fast. So you take any other number, children, you'll get the same. 63, let us say. 6 plus 3 is 9. 63 plus 10 is 73. This is also 10, like that. So either 1 or 10 you'll be getting. Okay, please note it fast. Okay, so please note this quickly. Let us go to the next question. Next page. Please note it fast, quick. Let's go to next question. The number of positive integers less than 1000 that are divisible by 3. Number of positive integers less than 1000 that are divisible by 3 means they are multiples of 3. They are multiples of 3 is. So, how many positive integers? So, you should check, children. First number is 3, second number is 6, third number is 9, and so on. And last number is 999. Okay, 999. So, you take the difference of these two, 999 minus 3. Okay, so that is 996. So the difference of those two is 996. Okay, so or otherwise you can take simply 999 numbers you are getting, so which are multiples of 3. So you divide this 999 by 3. So you'll be getting number of digits or not. So 999 by 3 you take. So this is 333. So total of numbers that are lying between below 1000 but and positive, which are divisible by 3, are 333. So option B satisfies. Please note it fast. See this method 999 minus 3, this logic where we'll be using if we use arithmetic progressions. So total number of digits are 996. Difference is 996. So you can use this in AP, arithmetic progression. So there, this will be helpful for us. Okay. But anyway, let's use a simpler method. So this dividing by 3 will give you the number of digits, number of numbers. So now we look at this. If n cube is an odd integer, n cube is odd. So compulsorily n is odd. Then only n cube will be odd. Which one of the following expressions is an even integer? So 2n square means 2 into odd is even, even plus 1 is odd. 2n square plus 1 is even plus 1, that is odd. So now what is that he said? Which one of the following expressions even is an even integer, he said. So a is not even, it is odd. N to the power of 4, odd into odd, that is odd. So this cannot be even. N square plus 1, this is odd plus 1, that is even. So option C satisfies. So n is odd means odd into even is even. So n into n plus 2, odd into n plus 2 is again odd, isn't it? Odd plus 2 is odd. This is not even. So only option C satisfies, right, children? Please note it fast, quick. This is option A. This is option B. This is option C. This is option D. So only option C satisfies. See, as this is in these cases, these are only single option questions. Once we get answer C, we need not check with option D. We can just leave it like that. So, but just to show that it cannot be even, I have done this option D. Okay, quick. Let us go to the next question. Yeah. If the product of two integers is odd, means compulsorily both should be odd. A may be equal or may not be equal. So A comma B is odd, we'll say, instead of saying equal. A comma B, both are odd. And if the sum of those two integers must be what? So odd plus odd is even, must be even compulsorily. And this is divisible by the difference of two numbers, not necessarily. So only one option should be right. So option is B. Please check it quick. Note it. Okay. So you have taken screenshot. Let us go to the next question. Here we write sum A plus B is odd plus odd. That is even. Like that. So that is why we are getting option B. Let us go to the next question. An odd number added to itself an odd number of times yields. So let us say A is odd. Now what is that he says? An odd number added to itself an odd number times means A plus 3A, like that you take. So this is odd plus odd. That is even. Okay? Or otherwise, 4 times something. 4A you'll get, isn't it? So that means now we got certain points to talk about or think about. So A is an odd number. Yields an odd number, he says. No. We are getting even. So option A is wrong. An even number, yes, it is right. Prime number, no. A positive number. So if he says A is a positive number, then these could have been positive. When he did not say A is positive or negative, I cannot say that a positive number. So therefore, option is only 1 minute. Why he's saying an odd? An odd number added to itself an odd number of times. So you'll get even. So option is B. This is B. Right, children? So let us go to the next question. Yeah. If the sum of three consecutive integers is odd, sum of three consecutive integers is odd means what? So A, B, C. So if I call them as n, n plus 1 and n plus 2. So this is odd, he says. So that means n, if you take it as 2, this is 3 and this is 4. If you add these three numbers, you'll get odd. This is 6 plus 3, 9. Odd means compulsorily first and last should be even. If you start these two as odd, so that means if you take 3, 4, 5, 3 plus 4 plus 5 is even. So now if he says this, if sum of three consecutive integers is odd, means A is even, C is even. Then the first and last numbers must be even, right? So even and even. First should be even and last should also be even. If first is odd, last is odd, you'll get answer as even, not odd. Therefore, option D satisfies. Please note it fast, quick. So let us go to the next question. Yeah. If L, M, and N are positive integers such that L is less than M is less than M means N is greatest of all and N is less than 4. So what is that? N is less than 4 means N should be 3. If N is 3, then M should be 2 and L should be 1. Compulsorily, this is the only thing. So then M should be what? 2. Option C. Quick, quick. So children, let us go to the next question. Yeah. If two non-zero positive integers P and Q are such that P is 4Q. So this is very important. P is 4Q. And P is less than 8. Less than 8 means what? Compulsorily P is 4Q when he says and P is less than 8. So Q should be 1. So P equal to 4. P is less than 8. And multiple of 4 means compulsorily Q should be 1. Right? So please note it fast. Quick. Quick children. Okay. Let's go to the next question. Yeah. N is an integer. N is an integer. Then which of the following expressions must be even? So N is integer means what? It can be odd or even. So odd square is odd plus 1 is even. So which of the expressions must be even, he says. So look at this. If N is odd, if N is odd, N square plus 1 is even. And N into N plus 2, odd into odd is odd. N into N plus 1, odd into N into N plus 1. So N is odd, we have taken odd into even is even. So if you take N into N plus 4, when N is odd, odd into N plus 4 is odd, that is odd. So you see you are getting like this. If N is even, for example, so N square plus 1, even plus 1 is odd. Okay. So that means N square plus 1 can be even and N square plus 1 can be odd. You take N into N plus 1, N plus 2. That is, N is even, we said. Even into any number is even. So next, N into N plus 1. So N is even into any number is even. Next, N into N plus 4. Even into any number is even. You see, in both the cases, even is there only for N into N plus 1. So the answer is C. Okay, please note it quick. So quick. Okay, let us go to the next question. P and Q are different prime numbers. And PQ by 2 is also a prime. PQ by 2 is also a prime. Then P plus Q. See, PQ by 2 is also a prime, he says. Means it is divisible by 2. PQ is divisible by 2. Okay. So that means either P is 2 or Q is 2. Any one of them is 2. So now then P plus Q means 2 plus all others are odd. So that is 2 is even, even plus odd is odd. Okay. Now look at this options. An odd number, P plus Q is an odd number, and he says it is even, no. A prime number, not necessary. If you take 5 plus 2 or 7 plus 2, 9, it's not a prime number. A negative number, no. So only option left over is an odd number. So again, children, like when we have proved it is odd, we need not check BCD because they all are single option questions. Simply for your knowledge purpose, I'm discussing every point. Okay, please note it fast, quick. Okay, so let us go to the next question. Now look at this. The sum of three consecutive positive integers must be divisible by which of the following? See, this I told already. N in n comma n plus 1 comma n plus 2. These are the things. So if this is odd, even, odd. So compulsorily in this 1 will be 3 and again 2 you have, so it should be divisible by 6. Even if it is odd or even, odd, even, like this. So that means 2, 3, 4. Or if you start with odd, 3, 4, 5. You see 6 is the LCM, LCM of this is divisible by 6. LCM of this is also divisible by 6. So therefore it should be divisible by 6. So you have 2. It is divisible by 2. It is divisible by 3. Need not be by 4 and 5. So he has given two things. Sum of the three consecutive positive. Sorry, it is sum. Sorry, I'm taking it as product. So let us look at this again, reanalyze it. Okay. So let us say 2, 3, 4. So 2 plus 3 plus 4 is what? 6 plus 3, 9. So next, if it is starting with odd, 3, 4, 5. 3 plus 4 plus 5. So what is this equal to? 9 plus 3, 12. So now you take. So everything is divisible by 3 or not? Or otherwise, you take n, n plus 1 and n plus 2. Sum of these three. That is 3n plus 3. So that is 3 into n plus 1. So therefore divisible by 3. Here also this is divisible by 3. You take this way, numbers. You'll get divisible by 3. But actual mathematics process is this, children. Okay. So now look at this option B. Please note it fast. Quick. Quick. So let us go to the next question. Yeah. So look at this question. This is a lot of simplification is involved. M by this n plus 1 by m plus 1 by n is equal to what? So first we'll start this elimination. So if you take LCM mn plus 1 by n, so this goes up. So that becomes n by nm plus 1. Now again, you take LCM. So n into nm plus 1 plus n by nm plus 1. So if you take LCM, you'll get mn square plus n plus n. So n plus n is 2n. So this goes up. So m into nm plus 1 is nm square plus m by mn square plus 2n. Mn square plus 2n. So you have option A. Please note it fast, quick. This is simple, looks complicated, but very simple, children, because only taking LCM and simplifying, that's all. Right, let us go to the next question. Should have copied this, noted that. Yeah. Lucy eats 3 meals a day. Lucy eats 3 meals a day. At breakfast, she has 3/8 of the total. So let us say X is the total meal that she'll have in all three together. So breakfast is what? 3/8 of total daily calories. 3/8 of X calories. This is total calories, let us call. For lunch, she eats 50 calories less than 3/4 what she eats for breakfast. So she's eating for breakfast 3/8 of X. So now for lunch, she's eating 3/4 of what she had for breakfast, and 50 calories less means minus 50 is lunch. Okay. And for dinner, she eats this many calories. So dinner is X minus of sum of these two, 3/8 of X plus 9 by 32 of X minus 50, right? X minus. So if you take LCM 32, so 4 3 is 12 plus 9. 12 plus 9 is 21X by 32 minus 50. So this is 710 calories, she said. So this is what 32 minus 21 is 11X equal to 760 into 32. So X equal to what? By 11. So you're not getting anything which is not a decimal. So now, so look at this. So this is 32 minus 21 is the same calculation. So 920 calories you're getting. So 710 3 by 8x into 3 by 4. 3 3 is 9 and 8 4 is 32 minus 50. So this is okay. Okay. So now next is what remaining x minus of this. So if you take x common, 32 minus 21 is 11x by 32 plus 50. So he says less or more. So this should be 50 calories less than 3/4 of this. So this may be more than the minus of this. So minus or minus is 50. Good. So that is the mistake. So you'll get 660. So x is 660 into 32 means 11, 6 into 32. Okay. 60 into 32. So what is this 60 into 32 is, or we'll rewrite this so that it looks neat. See, total is X calories. Breakfast, it is 3/8 of the calories, 3/8 of total calories. Lunch, so 3/4 of 3/8 of X minus 50. Dinner, what is dinner? 710. So that is dinner is X minus this lunch and this one, 3/8 of X minus 9 by 32 of X plus 50. That is 710. So if you take this, this is 11x by 32 is 660. So x is 660 into 32 by 11. So that you are getting it as 1920. So this is 60 into 32. So this is 6 2 is 12, 6 3 is 18, 19, 0. So option is A. Note it, children, fast, quick. Okay. So this is how you need to calculate. Hope you have all understood the things and grasped what is being taught, and hope there should be no doubts. But in case you have any doubts, you're most welcome to put them in the chat so that we answer you. Right, children? Have a great day and keep going. Wish you all the best of luck. Thank you.